Hi, welcome to my lightning talk on the future of database development. I'm Steve Jones, and I'm an advocate at Redgate Software, and I'm also the founder and editor of SQL Server Central. So today I want to spend a few minutes talking to you about where I think we'll get to with database development. Now this is kind of a future view and a prediction, not for next year, not for 2 years from now. This is probably something further in the future. So let's go ahead and start talking about software development first. Now, in my career, I think software development has gotten simpler across time. At least, it's simpler than it was for me when I was a lot younger. Often, to even get started as a developer on a project, I had to install software and follow some instructions in an email or maybe in a README. You have to track down files, track down software, check versions, maybe make configuration changes. Lots of that stuff I had to do myself to get set up, and it was always a pain. And even if I was experienced and I was just switching projects, this is something I had to go through. Now, things were never up to date, things never worked smoothly. And these two novels I have here kind of talk about this problem, or maybe the prospect of software development from the idea of fiction, right? So in the first novel, The Phoenix Project, we see on the left, Gene Kim, Kevin Baer, and George Spafford talk more about DevOps and a project that's late and how do we get it back on track? How do we help this company work? It's exaggerated and it's fictional, but many of the things and the problems and the challenges they face in there are things I've faced throughout my career in different companies. So it is somewhat based in reality. Now, The Unicorn Project is a newer book, and it's really a sequel, though you could read it on its own. In this one, Maxine is one of the characters from the Phoenix Project. We focus on her in the Unicorn Project. And while it still is on the software development side, it's a little more on the infrastructure side of how do I get all this stuff set up and work with people to ensure that I can actually compile my software and get it deployed somewhere, which is one of those struggles. Now, I recommend both these books if you've never read them. They're kind of fun, easy, light reads, and they're interesting. But modern software development has gotten much easier than it's portrayed in that book, and certainly much easier than it was for most of my career. Often, all of our code is stored in some sort of repository. Git's usually, I think Git is one, right? But it could be in TFS or Subversion or something else. But we have a repository of code. We have these package managers that will handle dependency issues for me and pull that stuff together, which is fantastic. Most of us in the data world don't quite have this. We don't really deal with the dependency issue very often, but for you in the software world, it's incredible. Of course, we have all the automation testing stuff of DevOps that we try to get done. And then lastly, containers are an area that I've been looking at for a little over 10 years, and I continue to look at, but they really do dramatically improve the ability to smooth software development. So we have all these tools. And as an example, I actually just went on the internet and I searched out a random .NET project. So in this case, I found this eShop on Web project, and all I did was go to the repository and I clicked the clone button, and it gave me this URL that I put here. And so I typed git clone and pasted in the URL and hit enter, and then it started downloading right away. Now you can see the day I did this, it actually paused briefly. There was this little bit of a delay, but it's pulled down all of this code for me, right? I didn't have to do anything special. And then I'm just going to run this Docker Compose command that will start up and build the software and build me a web server that I can then run with the Docker Compose up. And you'll see near the bottom it's listing on port 80. Now on this laptop I actually don't have a web server running, but I can go to localhost on this port that popped up in that in the command line, and I have a full-featured MVC application running. I can click on things, I can do things. I have a piece of software running, and now I could go in and alter this code and recompose it, and then run it, and everything would work well. Now, the developer has done some scaffolding, right? He's put in the configuration for Docker and all those things, but I didn't have to do anything on my machine for that to just work. And that is a huge advantage. And really, that's where Microsoft has gone with code spaces and some of the things they showed at Ignite and Build. They're trying to make it easy so that we can just run software, and then we can build it without having to worry about a lot of the cumbersome things we've had to in the past. Now, this is good for the application. But when I get to the database, it's a more of a problem. That I have to typically have some separate database hardware that will host this thing. I have to install the database platform, right? SQL Server, Oracle, Postgres, whatever it is. Then, storage, where am I going to keep the data, and persist it and all that stuff. And then, of course, I actually need data if I'm providing an application for somebody when they're trying to work on my project. And then what about resetting that environment, right? If I, stop a .NET application and restart it, it starts up with the same state. But for the database, that's not true, right? If I've changed something, if I've added a row to test something, how do I reset that? How do I ensure that myself and others can constantly work from a good foundation? And then what about branching, right? If I'm branching code, the database maintains state, and branches kind of assume that we can move things around. And there's all sorts of challenges here. Now, we can get around some of these things, but it's a problem. And as an example, if I go back to the README for this application, you can say, if I want to run this in a container, there's just two commands that I run. But if I want to use SQL Server, I have to go edit the configuration. I have to ensure that things are there. I have to make sure .ef is actually running. Of course, I have to have a SQL Server there. It's not quite as simple as it would be with a container and Docker. And yet I want all that thing. So what I really want is a container to simplify my database development. That I want to have immutable containers that run the same everywhere, so that if I give you access to my project, you can run it. Now, I can do this. SQL Server can run inside containers, and matter of fact, most data stores run in containers. And I can package these up with my application and allow somebody to bootstrap and get running on a software project. I'm not talking about production. Containers do work in production, but this is just for software development, database development. So I want to give you an example of this. Now you'll notice I have no services running here for SQL Server. All three of them are stopped for the different versions. So I'm going to run just a yarn command. Now yarn is a package manager that does some things. And what it's actually going to do here is it's actually going to look for some database containers. And if the database containers don't exist, in this case they don't, it's going to create those containers, which will be my database platform. Now I'll also have an application running. And in this case, it's actually just going to run from its own container where it's going to do some work. But the key thing here is for the database development is that I'm programmatically creating a container, I'm getting some credentials back, which will then be used to configure my application to run. In this case, I'm actually updating the container with code changes. So at the bottom it says migrating schema. These are actually the scripts that developers would have written to say, we're going to add a table, we're going to add a proc, we're going to do these things. We track those and keep those with our source control, but then if those aren't applied on the database that we're going to use, in this case in a container, we're just going to apply those changes so that when a developer starts this up and runs, they get the latest version of the .NET code and they get the latest version of the database code as well with the data. And so in this case, once it starts up, it tells me the port that's running. I can log in here. You can see, again, I'm running on localhost where I don't have a web server here, but it's spun up in the .NET application. In this case, I log in, and then I've got a database. I've got some items, and I can do different things that I want to do and then access it. Now, all of this comes about because of this Spawn project that actually is in beta now. But the idea is that I'm actually going to build a database as a service here. So rather than requiring a developer to do something, we're going to provide that as a service. Now, this could be from my internal IT group. It could be from Microsoft and Azure or AWS from Amazon. Or it could be something like Spawn, where there's a vendor that allows you to store container images and then provide them. But the idea is that we spin up these Docker containers that have your data, that have your security, that have the things that matter to you. They have all the resources available. We allow you to do this programmatically, and then developers can just get started. So spinning up a database now becomes just as easy as spinning up an application. And I think this is what's going to happen. Here's kind of the container lifecycle where we create a container, we commit some code there, we validate the code, produce a new image goes, and we kind of work through this cycle over and over and over again. But the key is that the developers just make their changes, and then the process updates itself over time. And ultimately, I think where this will go is that we'll have things like Kubernetes that allow us to manage large numbers of containers as needed for our developers and our applications to ensure that we can actually, get the system up and running quickly and ready to go. So really my view for the future is that we're going to have containers for data stores. We're going to use data virtualization for storage, which is a separate topic, but it is something that's available now. We'll use package managers like Yarn and NPM to integrate with these containers and update the application so configuration goes away. We'll use Kubernetes or some orchestrator that happens for the scaling. And then being in a DevOps flow with CI/CD allows us to ensure that the images are always updated. Every day developers restart with a new version of the image and a new container, and they have the most up-to-date code from all of their teammates. I think this is a ways away. I really think this is in the 8 to 10 year time frame. I first started to speculate this, talk about this about a year and a half ago. I still think we're probably at least 8, maybe 10 years away before this is kind of the default way of us setting things up. There are some challenges here that I've listed. Certainly there's the things that we have to work through as an industry and as vendors and as software developers, but all of these are solvable. They're just things that we have to get up and running. So hopefully you enjoyed this session on the future of database development. I'm Steve Jones. There's my contact information if you want to get a hold of me. SQL Server Central and Twitter are the places to usually find me. And don't forget, feedback's important, so fill out your evaluations. Thanks a lot and enjoy the summit.